Now lastly, we have another orbit which is called as geosynchronous transfer orbit, or GTO. Now when we talk about this particular orbit, this is a special case of an orbit where what happens is that this orbit will take the satellite from a low orbit to a high orbit, from a low Earth orbit to a high Earth orbit. Normally when we launch a satellite, so we discussed that there is a low Earth orbit and there is a high Earth orbit. When we launch a satellite, the satellite by itself directly cannot be launched up to high Earth orbit. Please remember this, that it's not possible for us to launch a satellite to high Earth orbit. So for that very purpose, we need a special kind of orbit which will be able to take the object from low level orbit to the high level orbit by its own mechanism. And this particular orbit is called as geotransfer orbit or geosynchronous transfer orbit, or sometimes is also called as Hoffman transfer orbit. So this is a special case of an orbit. If you look at this particular picture, this is what happens, that when it has been launched, initially it will be launched from here up to here. The satellite will be launched up to this point. From here the mechanism of GTO takes over, and what now happens is that this kind of a mechanism will happen, that it will keep on increasing in size, and ultimately you will see that it will reach a point which was required. It will reach this point, and after reaching this point, this orbit will be taken by the satellite. So we started from a very small point which was very near to the earth, and we have kept apogee. If you remember, we discussed this term apogee. We have kept apogee as 35,786 kilometers, and once the satellite comes to this particular point, after this it will take the normal course of its orbit. So just remember that when we launch a satellite, we don't launch the satellite to the geosynchronous or the geostationary orbit, but we rather take it to the point of GTO or geotransfer orbit, and from there on this mechanism of GTO will take over and it will take the satellite where it is required. The exact mechanism how it works, not required for the examination. So it is an elliptical Earth orbit used to transfer a spacecraft from a low altitude orbit or a flight trajectory to a higher orbit. Apogee is at approximately 36,000 kilometers, and when a spacecraft reaches this point, its apogee kick motor is fired to inject into a higher orbit. So as soon as the satellite has been taken to this particular point, from here on there will be additional fuel that will be kept, and this additional thrust will be provided at this particular point, and from there on the mechanism of GTO will take over, and ultimately you will see that it will reach the point that was desired. So this is a special kind of orbit which is called as geosynchronous transfer orbit. Now the next portion that we have from here is on the basis of the different kinds of satellite and the applications that we have for different kinds of satellites.